I'm Zachary Karcher and this is my modified tutorial 8. In the basic tutorial, you simply use a photoresistor mixed with an LED so that the LED will turn on more as the room gets darker. In my modified version, we add 10 more LEDs, a second photoresistor, as well as a piezo that will beep every time it gets to one of these ends. The purpose of this circuit is that it will travel from this end to this end as long as this LED it has sense light and this one hasn't sense light. As the reverse is true, it will go back from this end to this end. To begin, we'll take a look at the physical circuit. Note, as I point out the components on the circuit, the schematic symbol for such components will appear in the top right corner. Starting off, we have the two photoresistors, here and here, which are variable resistors which react to light and limit the resistance. Here we have the 11 LEDs, which are light emitting diodes. Then we have a piezo, which converts electricity into vibrations which produce sound. Here as you can see here, these resistors are used to create a voltage divider. This is because the photoresistor changes its resistance based on the light to which it is exposed. To use this with the 101 board, you need to build a voltage divider with a 10k ohm resistor as shown in the wiring diagram for this experiment. The 101 board cannot read a change in the resistance, only a change in the voltage. A voltage divider allows you to translate a change in resistance to a corresponding voltage value. Finally, I am using the SparkTera board, which is a solderless breadboard with a built-in Arduino 3 board. Here you can see the working circuit, as well as the serial monitor printing on the left. As you can see, the direction will change based on which photoresistor is covered. Also, as you get to the end, you hear a piezo beep. You can also see how the numbers change based on where the circuit is in the code on the left. Now moving on, we'll take a look at the schematics for this tutorial. Looking here, you have the LEDs, which are connected to the board via these wires and then back down to the ground, represented by these junctions. Here you can see the two photoresistors, which are also connected to the circuit, both to the power and the ground. And as well as the volt dividers they're connected to. And here you can see the piezo, which is connected down to the ground and as well as to the board. Finally, we will talk about the code which allows this circuit to function. Starting up here, we will assign variables which allow us to assign ports to the different sensor pins of the photoresistors. Here, we will assign them to the analog ports 2 and 0. Down here, we do the same for the LED pins, setting them to ports 2 through 10, as well as 11, and then the piezo on 13. These are important because these are variables which will set the calibration values of the sensor pins, which will be used to check against the variable one which is constantly being updated in the circuit. Next, in the void setup, we will begin printing to the serial monitor as well as setting all our LED pins to output as well as the piezo, and taking another initial value for the sensor pins. Here in the void loop, we will begin by printing out all our values to the serial monitor, including the light val, light calibration, light variable 2, light calibration 2, and the counter. Down here, we will take the two variables now so that it will constantly update in the circuit. Here, this says that if the photoresistor 1 senses light and photoresistor 2 doesn't, add to the counter. this one does the opposite, whereas if the variable senses that the photoresistor 1 doesn't sense light and this one senses light, then it'll go the other direction. And that works by subtracting from counter. This is used to prevent counter from ever going below 0. Basically just saying if the counter does go below 0, reset it back to 0. Now, all these counter equal things are structured identically, so I'll only go over one. So this says that if the counter is equal to 1, turn the first LED on, all the rest off, and play the piezo tone for half a second before shutting it off. The only difference is that these other ones, all except for 10, do not have the piezo. This continues till the end, where we have if the counter becomes greater than 1, just go right back to 10.